So we reviewed graphing those equations. We're going to look at graphing tonight in a little, at least for the first part of tonight, in a little bit different form. We're going to look at graphing data. We're going to start out with just organizing data a little bit. And there's two types of data that we're going to look at. Categorical and numerical. Now, just because the one is numerical doesn't mean there isn't calculations we can do with the other one. There are a lot of calculations we can do. But what it's talking about is it's talking about the variable. We're going to be dealing with the statistics tonight, the statistical graphs. When you're talking about statistics, you're answering a question. And you're asking a question. And the answer to that question, the type of answer, is what determines whether we're looking at categorical or numerical data. If the answer to my question is a number, then it is numerical. How tall are you? How much do you weigh? What is your grade point average? How old are you? I'm not going to make you answer any of those questions, but those are examples of numerical data. How many cars do you own? How many kids do you have? How much money do you make in a year? If the answer to the question puts you into a category, it's categorical data. What's your favorite color? Do you own or rent your home? Do you own your car outright? Are you leasing your car? Are you making payments on a loan for your car, or do you not have a car? Any yes or no question puts you in is categorical. Do you approve of this new bill that's been proposed, or whatever? Yes or no questions are all categorical. They put you into categories. Categorical data still has numbers because there's still the number that are in each category. If it's a yes or no question, there might be 70 yeses and 24 no's, or whatever. There's still numbers involved, but it's the answer to the question that's categorical. They put you into a category. So anyway, we're going to start out looking at the categorical data. And how do we organize that? Let's say we ask you what your favorite color is, and I give you the choice between blue, red, and green. Let's just go around the room. Again, those are your only three choices. You got to pick one. Now, Richmond, what's your choice?
I'm going to go with
Red, okay? There's one for red. Let's just start here. Angie? Red. Belle?
No.
Blue? Natalie? Green? Amy? Blue? Jordan? Green? Red. Okay. That's pretty boring results. I'm going to put my results in there too. I'm the teacher. I get to pick twice. There. Okay. So now we want to organize that a little bit. I'm going to put it in a table. The first step in organizing data is almost always some form of a table. What we're making here is called a frequency table. Why is it called a frequency table? Because it takes each category, in this case color, and it gives a frequency. How frequently did that answer occur? Well, blue occurred how many times? 2, red, 4, and green, 3. Now, would it have made any difference if I had listed red first and then green and then blue, or green first and then red and then blue? No, there is no logical order that these have to go in because they're categories. It really doesn't matter which one comes first. That's something very important to remember. We'll talk about that later. There are several things I can do to organize these now. One thing I can do is a simple bar graph. bar graph, when it's dealing with categorical data, can be done one of two ways. It can either be vertical, which is the standard bar graph. In a vertical bar graph, the categories go along the bottom. In this case, color. Bless you. That sounds almost like hurt. So our categories go along the bottom. Blue, red, and green. Along the left side, then, we have to have a number scale. Now, what's the largest number we need to get up to here? 4. So we really only need to number up to 4, or at least to 4, I should say. So 1, 2, 3, 4. We'll go up to 5, because 5 is a nice logical spot to stop, right? And now for each color, we make a bar that goes up to its frequency. Blue was chosen twice. Green was 3 times. Blue is just 2. Red was chosen 4 times. So we're going to go up to 4. Green was chosen 3 times. And so if you want to know, if you're asked the question, how many people chose red? You find red, you go up to the top of the bar, you trace it over. Hey, that's 4, right? So on. So you can find that. A bar graph is not great for that purpose, by the way. If you want to know how many people chose red, it's easier to look at the table. Hey, there's red, it's 4 people. What the bar graph is great for is saying, what color was chosen most often? Chosen most often. Chosen most often. Red, because its bar is the tallest. Which color was chosen least often? Blue, because its bar is the shortest. Now, in this graph, we could very easily say green is 3, blue is 2, red is 4. We could find the exact number, the exact frequency. But most of the time in a bar graph, that's not the case. For example, let's say we want to compare 3 companies, comparing net sales. And just because that's how creative I am, we're going to call them companies A, B, and C. And because we have to get up to some large numbers, I'm going up, each mark is worth 5, and I'm only labeling every other one, so 10, 20, 30, 40. And technically what that stands for is, this is sales in thousands. So this isn't really 50, it's 50,000. So I'll put the bars in. The sales for company A, there. Company B, there, company C, there. To make my point, which company had the most sales? C. Least sales? B. Very good. If I had to choose between company A and B, which one had more sales? A. I can compare, so now I can find the most and the least I can compare to really quickly. But if I ask, how many sales did company A have? Technically, it has 48,623, right? We can see that right on the graph pretty clearly, right? No, we can't, can we? We can say it's, 48 or 49,000 is about what we can say. We can't get an exact number off of a bar graph, at least not in this case. I mean, over here we could because we're dealing with really small frequencies. Yeah, once I wrote it on there, now you know it, but... Yeah, but I mean, if it weren't there, there's no way you're looking at that bar and reading off 48,623. Not going to happen.
You call me the math Nazi.
Oh, yeah?
Accounting Nazi.
Okay. I'm going to leave it alone. There's nothing I can say there that would make it any better. So that is the weakness of graphs. If I wanted to know the exact number, somewhere there's a table that lists companies A, B, and C and what their sales are. And we read there and we get the exact number of the table. Or at least as exact as they give it. They may have it rounded off to the nearest 100 too, who knows. But Now, the other way this could have been done is we could do a horizontal bar graph where we have blue, red, green like this. And of course, 1, 2, 3, 4. Maybe we'll go up to 5 again. And of course, the bar for blue goes to 2, red goes to 4, green goes to 3. There it is. It's that simple. Not brain surgery? Okay. Another thing that can be done with categorical data, very common, is something called a pie graph or a pie chart. For those of you, a couple of you mentioned Excel. When you're in Excel, they call them charts instead of graphs. A bar graph, actually, in Excel is called a column chart. And there's about 27 different variations of it. Pie graph, pie chart, requires us to modify our table a little bit. So we've got blue, red, and green. Had our frequencies of 2, 4, and 3. A pie chart, or a circle graph, depending on which type of data you're using, does not usually express raw numbers. What it usually expresses is percentage of the whole. So usually we put in a percent frequency. How do we find a percent frequency? Well, our first step is to find a total frequency. If we add those all up, we get 9. So the percent frequency, well, blue is 2 out of 9. That out of 100, that is 22.2%. Red is 4 out of 9. Out of 100, that is 44.4%. Green is 3 out of 9. That is, out of 100, 33.3%. Now, if I add up these percents, what should they add up to? 100%. If I add up those 3%, what do they add up to? 99.9%. Is that okay? Yeah. A lot of times we're going to have 99, sometimes even 99.9 or 99.8 even. And that's because, sometimes 100.1 even. That's because all those percents are rounded. And in this case, all of them are rounded down slightly. Doesn't mean you're off. I mean, if you got like 97%, you would want to worry. Something's probably wrong. Now, if this were the old days, what we would do is we would take a circle and say a circle is 360 degrees. And we say, okay, what's 22% of 360? That's, what, 70 whatever degrees. And then take out your protractor and mark it out and find that many degrees, and it's nice and perfect. Now that we live in modern times where there's computers, if we wanted that perfect, beautiful little pie chart, circle graph, we'd use a computer program to do it. Excel does it really nicely. So we don't have to be that precise doing it by hand anymore. But what I do want to make sure that you know, or that you realize, half a circle is what percent? 50%. A quarter of a circle is 25%. Using those benchmarks, we can put the rest of this in. 22.2 is a little bit less than 25, right? So maybe like that. That is blue. 44.4 is a little bit less than 50. Now it's a little bit, this was only about 3 less, this is about 6 less, a little bit further off than that. That's going to be my red. What's left here, of course, has to be green. 33% is about a third of a circle. That looks about right. Does that make sense? That is good enough for what we do. Now, reading the bar graph, we went over. That's pretty simple. You just follow it over. Reading a circle graph or pie chart can be a little bit more complex. Let's say A equals 38%. B equals 31%. C equals 12%. And D equals, what's that come out to be? 19%. Very good. Obviously not drawn to scale. It's a little off. Out of 200 items, because I don't really know what A, B, C, and D are describing, but they're describing certain items. How many are type D? Well, type D is what percent? 19%. Out of 200, so cross multiply and divide to get there's 38 out of 200 are type D. That's not so bad, right? Has he did it for a second here? He's got it. Okay. Does that work out? No, it don't. It says 30. Okay, so I've got circle graph here though. These are not percents. These are just numbers. A is 7, B is 15, C is 28, and D is 30. What if I ask you what percent is B? What's the first thing I have to find? The total, which appears to add up to 80. Now what? Blank out of 100, because the percent is out of 100, is B is how many? 15 out of 80. If I cross multiply and divide, I get, what's that? 12, something's off there. Isn't it? So 18.75. How do you put in 10 instead of 15? Any questions? Now, another way that data can be expressed, and usually categorical data, is something called a pictograph. Pictographs are the darling of the media. Magazines, newspapers, even now television news, if they show a graph, they love to use pictographs because they're pretty and they're flashy and we can make them colorful. They are also, to a pure statistician, pretty much as close to the devil as you're going to find. They can be very misleading, and they're difficult to read. And if you're not very careful, they can be extremely misleading. Let me show you an example. Let's say we do a survey on how you get to work, on your commute. And let's say the options, the responses we get are walking, riding bike, driving a car, asylum van, public transportation, a bus. Notice what I did after each of those symbols? I put equals a number. This is what would be called the key of my graph. So on my pictograph, Again, that's not just bus, that's public transportation, but that's okay. What's that last one? Yeah. I know, my heart sucks. Because it's not a full 25, it's 22 or 23. That equals 5, so it's 5, 10, 15, 20, 23. Yeah. There we go. Fine, I'll give in. Ruin all my fun. I see how you are. There. What's that? Oh, no, this one is graded for artistic presence. What's that one? 20, 40, 60, 80. That's like 17 or 18. That's more than 10, obviously, more than half. At least 15, but not quite full 20. There's a reason for that. There. What's that? Here, I do this. I draw better. I just do a horrible job drawing. You're done? There. Okay, there. Just glancing at this graph, turn off your brain for just a second and pretend you're the average American consumer. I know that was me. But this is what media and advertising and everybody depends on, is that you're not going to think, you're just going to look and trust your first reaction. So I didn't mean that statement to be cynical. It's the truth. It's what advertising companies depend on. Looking at this graph, if I ask you very quickly, what's the most used mode of transportation to get to work? Bus. If you shut off your brain. You look at it, the bus goes way over to here. But each of these is only 20. This is 20, 40, 60, like 70, a little over 70, 70 to 75, right? Somewhere in there? Maybe 72, 73. This is 20, 40, 60, 80, like, I don't know, 95 to 98, somewhere in there. Who knows? Much more people took cars. If I asked you between bikes and walking, what's more? Got 5, 10, 20, or 15, 20, 23, let's go. 10, 20, 22 or 23, right? Maybe 24. Really hard to tell. They're almost exactly the same. The pictograph is very deceiving. You have to think. I worked for a while at University of Wisconsin-Madison Statistical Research Center. This type of thing we did intentionally a lot. I know this is going to be caught on tape, but I don't care. Mark Twain once said, there are lies, there are damn lies, and then there's statistics. There's a lot of truth behind that. Statistics are true, but they can be twisted to say whatever you want them to say. Here, all the numbers presented in this graph are true. But if I had to take a guess, this was probably a study done or information put out by the company that runs the city bus service trying to get more money for more funding or whatever for whatever. Trying to show that, hey, look at the number of people that take buses to work in the morning. And that gets done a lot. Accurate statistics, very accurate statistics, just displayed in a deceiving manner. Another way of doing it, this looks like a bar graph, but it's actually a pictograph. I'm going to compare two companies, company A and B. Obviously, which company has more revenue? B. Would you say double? Triple? Double? This graph is actually read like this. A is just under 5. B is just under 6. Just a little bit more, only 20% more. But because of this three-dimensional aspect to it, that difference is magnified and distorted to make B look like it's a lot more. Well, it's just a little bit more. If you're working in Excel, you have 3D column charts. They look really pretty, very deceiving. Now in Excel, they're usually, they have an equal depth, so it's a little less deceiving. But you can, in some other graphing software, you can distort the depth of them. And just, if you have a bunch of bars that are the same depth, like this, well, then it's not so bad, because they all have equal depth. So the difference in height is just the difference in height. But if I take one of those and now distort the depth of this bar, they still have the same difference in height. This bar just looks a lot bigger because that extra depth. If you stop and slow yourself down, you see the height, but even then it's really hard because your mind wants to grab onto area, not height. There's a lot of psychology behind advertising and use of statistics and marketing and stuff like that. Here's another one that comes into play. Remember this little graph here, this little bar graph, A, B, and C? I'm going to do something very similar to that. Still a bar graph, but just not a very statistically accurate one. Looking at these, comparing company B to company C, what would you conclude comparing them? Yeah, C is almost double B, isn't it? But look at the numbers. And again, we can't get exact numbers, but this is probably about 66,000. This is probably like 64,000. And this is like 71 or 72,000. Not a huge difference. Why does it look so big? This little symbol right here. We went from 0, we jumped up to 60 instead of numbering from 0 all the way up. If we had numbered from 0 all the way up, this bar graph looks something like that. With the election coming up in the next year, you're going to see a lot of graphs like this. A lot of graphs like this. But they don't start at 0, they start like right here. Saying, this is the public approval for Plan A, this is the public approval for Plan B. See, the public really, there's maybe 2 people more on one side or the other, but boy, look at how big that is. You'll also notice most political surveys, there are roughly 200 million registered eligible voters. I should say they're already eligible voters in the United States. Most political surveys, maybe a couple thousand people. Actually, I shouldn't say this on recording either. I get that phone call every now and then, and I have a lot of fun with them.
They ask the same questions over and over. They
What?
tweak the words a little bit.
I'll explain why that is.
Oh my gosh, seriously, I have things to do.
There's two reasons for that. If it's a legitimate survey, they are tweaking the words. Like they might ask they'll ask the same question in a positive and in a negative.
Oh
Like,
yeah.
are you in favor of increasing funding for the schools? Well, yeah.
The last one I did was all about Hillary Clinton and releasing
Yeah.
of the emails and stuff.
Sure.
Like they tweaked, they changed one word in the sentence like 6 times.
Yeah.
And I'm like, seriously? I can't do this anymore.
Well, like I said, there's two reasons. Like I said, if it's a legitimate survey, they'll ask you, are you in favor of increasing funding? Then later on, they'll ask, are you opposed to increasing funding? To make sure you answer yes to one and no to the other. Because if you answer yes to both of them, then you weren't really paying attention. Or your opinion changed in the 5 minutes of the survey. No, the other reason they do that is not all those questions are really part of the survey.
Yeah.
They're going to pick which questions are part of the survey, depending on how they're answered. So they'll answer, and the way the question is worded could change how you answer. Maybe they're not actually even doing the survey there. What they might be doing is designing the survey. Because deciding, okay, we're going to ask this one person 20 questions. 10 of them are going to be the same question worded different ways. But okay, in these 10 questions, I'm just going to do this. Maybe 3 of them are the same question worded 3 different ways. We asked these questions of 100 people. Question 1, 72 said yes. Question 2, 19 said yes. Question 3, 54 said yes. If we want the answer to be yes, this is how we're going to word it when we actually create our survey. This wasn't really a survey to answer those questions. This was a survey to design the survey that they were going to use to answer that question. So now, once they've picked what questions give the most answers that they want, now they'll design the survey, conduct the survey, and they can honestly go on the news and say, look, 74% of the people say they don't really care. Let it go. Or whatever.
Try and answer the question with one that's not listed on their sheet or whatever they're reading off of.
Oh, yeah.
My gosh, it's like, oh, hell breaks loose.
Well, that's what I do. That's what I do. And they call, well, in there.
You can't give me that answer. I need this one, this one, this one, or this one. And it's like, I don't want to answer those.
If you choose to vote in the Republican primary, will you vote for Donald Trump, Ben Carson, or Richard Nixon? Well, that's not one of the options, sir. Well, we got write-in votes in this state. But if you were required to vote for one of these, which one would you vote for? Ronald Reagan. Well, that's not one of the people. Well, that's who I'd vote for. They usually hang up on me.
I'll have to try that next year. I'll try to get rid of it.
If Hillary Clinton were to appear in front of the Congress, would you be in favor of this? Firing squad. Well, that wasn't one of the options. That's what I'm in favor of. Sorry, that's not very nice. I haven't been getting many of those calls lately, so I think I might have got put on a list.
Maybe that's what I got to do. I would have thought that the kids in the background, the guy would have been screaming in the fight.
Actually,
they could care less.
You think that would be an issue? Not necessarily. A distracted survey taker is sometimes an advantage.
Oh, heck yeah, because I would just answer as fast as I could answer. Get off the phone, and I think it's still like 20 minutes.
Another thing that happens is you do have the right to say, by the way, I'm not going to answer this, and please take me off your list and do not call back. Now, there are exemptions for nonprofits and political campaigns. Yeah. Political campaigns do not have to follow the call list. But if you specifically tell them, take my name, what campaign and what organization are you working for, and write down the name of that organization, and say, take me off your list, have me stricken from your list.
All right.
And if that organization calls you back, then you can have them penalized for it.
Huh.
So anyway, another thing that happens, other than what you were talking about, where they're testing the questions before they construct the survey, something like this. Let's say that there's a proposal to increase property taxes for school funding by a small percentage, a referendum, and they want to do a survey to see if the referendum is going to go. Let's word the question like this: are you in favor of paying more in property tax to fund school lunches. Now, we live in a society where very few people listen completely. At what point in this phrase would most people stop listening?
Paying more taxes.
Right there. Are you in favor of paying more property? No. To provide better lunches for our children, would you pay a few dollars more? In property tax. Of course, to provide better lunches for our children, would you? Well, yeah. You don't even hear what comes after that. Eliciting that emotional response in the beginning of the question. You're still asking the exact same question here, but the way you word it triggers emotions. Other things they try to avoid is always. Would you always do something? Or would you never do something? Absolutes are bad because most people shy away from absolutes. Another thing that gets done is something called a stack survey. And this is what I hated. I absolutely hated this. And this might have been what they were doing to you. I designed several surveys like this, where, and in most of those surveys, the person who is on the phone with you taking that survey knows absolutely nothing about what they're doing. They have no clue. They are reading a computer screen.
Yep.
And the computers, and they don't even, they just, when they're done with a call, they just click a button when they're ready to make the next call. The computer will randomly select a phone number, it'll dial the phone number, and it might not even be the same survey they were just working on. Whatever survey that person's getting called is supposed to be taking, the script comes up on the screen and they read it. And it gets to a question, if it's multiple choice, they select it, or if it's a number, they type it in or whatever, and then the computer pops up the next question. And they read it. Well, they don't know, and there's a reason, you think about when I mentioned, well, they don't necessarily do the same survey over and over again. Sometimes they don't want that person knowing the survey real well. If you know the survey inside and out, you notice discrepancies. A lot of times what will happen is at the end of like 5 questions or so, it's actually 2 surveys. It's not just a single survey, it's 2 surveys. At the end of 5 questions, the computer will determine, based on the way that this person's answered the first 5 questions, they are not going to answer the way we want them to. The survey's ended. This was not a survey, it was a screening. If we get to the end of those 5 questions and the computer program determines this person's going to give us what we want, hey, there's 3 more questions. And these 3 questions are actually the survey. This happens a lot. We used to get orders coming in from companies that were ordered by some sort of government regulatory agency. You need to do a study on this to determine what the consumer opinion is on this, or what a landowner opinion is on this possible environmental risk or whatever. And so, and we would get that order if we need to do the survey, and there'd be a little side note somewhere of this is what we need the result to be. So design a survey that's going to give us this result. It happens a lot. And this is one of the ways it was done. Now, another way it's done, the way your survey is selected, obviously you call people up and not everybody's going to answer. Less than half answer. Usually right around 30% will answer your questions. But if you get a phone call, political survey. Hello, this is Todd Hoff from the Wisconsin Republican Party. I would like you to answer a few questions on, well, what type of answers do you expect that from the people that do answer those questions? What type of answers do you think I'm going to get? Well, what's this? Let's say I make another to a different group of people. I respond to them answering the phone. Hello, this is Todd Huff from the Wisconsin Democratic Party.
Yeah, it completely depends on where you're calling.
Yeah.
If you say Republican or you say Democrat, depending on which way you are,
Exactly.
your answer.
If I say that I'm calling from the Wisconsin Republican Party and you're a Democrat, are you going to continue that phone call? No, you're going to hang up. Or you're going to yell at me and scream some bad things and hang up. But you're not going to answer my questions. So, what type of answers do you think you're going to get to those questions? Relatively conservative answers. If I say that I'm from the Wisconsin Democratic Party, the Republicans are going to hang up or scream or whatever. But the people who stick around and answer are most likely going to give relatively liberal answers. So little things like that can determine it. And don't think that's not done intentionally. It was in Missouri in 1996. There was a political propaganda that was sent out with the ARP logo on the envelope. It was not the official ARP envelope. And this is actually, and I'll name it, the Democratic Party did this. Sent out political propaganda with the AARP logo on the envelopes. Well, obviously they were targeting what population? Elderly. And having that symbol on there makes them much more likely to open that envelope because it's a trusted symbol. That gets done a lot too, where a political party or some other group, an interest group, will purchase the right to use a common logo. Maybe it won't even have the company name on it, but there are a lot of companies that even if you took, what company am I representing here? Chevy, exactly. Without any, I know, I am not much of an artist. I probably should have stretched. Probably should have stretched out more like that.
There you go.
But you recognize the symbol without the word there. That happens, and the symbol itself, there's a thin line where the trademark ends and where it's just an artistic symbol, a shape. That's done a lot. Okay, it is break time. Let's come back at about 4:32